My name is Nabila binti SALIMAN. Okay, today I would like to present on the introduction and the principle of gas chromatography. So first, let me define you what is gas chromatography. So GC is the chromatography technique that used for separation of volatile compounds. So what means by volatile compounds? So volatile compounds is the compound that easily vaporized at room temperature. There are many applications of GC that apply in food industry. For example, the termination of methanol and high alcohol in wine production. Next, the termination of fatty acid profile of oil in GC. Okay, next, stop there. Next, we will move to the principle of gas chromatography. So the principle of separation in GC is partition. The sample is transported into the mobile phase. So during a mobile phase, the phase can be a gas, a liquid, or supercritical fluid. Okay, the component which is more soluble in stationary phase travel slower and elute later, while the compound which is less soluble in stationary phase travel faster and elute out first. Symmetry diagram of gas chromatography. So first, the sample which is to be separated is mixed with the appropriate volatile compounds such as heptone, acetone, and methanol. Okay, then the syringe or septum allows injection of the sample. The temperature at the injection region is kept between 20 to 50 degrees Celsius. This allows the rapid volatilization of the sample. So after that, once the sample is volatilized, it passes down to the column. The separation occurs at the column. So during analysis, the temperature of the column is kept between 150 degrees Celsius to 300 degrees Celsius. Okay, the separation occurs based on the interaction of molecule between the mobile phase and the stationary phase. Just like I have mentioned before, either it is more soluble or less soluble. Okay, the separation is completed, the detection is done with a detector attached at the end of the column. The example of the detector is FID, which is flame ionization detector.
Function of the gas chromatography. Gas chromatography used in analytical chemistry for separating and analyzing the compound that can be vaporized without decomposition. For example, we can test the purifier of the particular substance, and then we can separate the different compounds of a mixture. This is the diagram of gas chromatography. There are four main components of gas chromatography. First is the carrier gas supply. Carrier gas supply used as the mobile phase. It helps to carry the injection sample to be analyzed by flowing the gas through the system. Second is the injector. Injector used as the inlet for the sample. Injector also used to vaporize and mix the sample with the carrier gas before it enters the head of column. Third is the column. Column used to contain the stationary phase and as the passing way of the mobile phase. It also as the site where the separation of analyte occur. There are two types of column, pad and capillary. Pad used for non-sample preparation and capillary used for the polar sample separation. The last one is the detector. The detector used to generate the signal and to be converted into chromatogram. It also helps to sense the presence of individual components after the sample leaves the column. For example, is the mass spectrometer, flame ionization, and thermal conductivity.
My name is SITI ZULAIKHA binti ISHAK. Today I want to present the advantage and disadvantage of gas chromatography. First advantage of gas chromatography is high resolution power compared to other methods. It's shown by the strong peak and symmetric peak. Next is high repeatability and reproducibility of retention time. Next is high precision and accuracy. in quantitation based on peak area measurement. For example, no discrimination of component through volatility, polarity, and concentration. Next is analysis sample very quickly, minutes, even second. Next is small sample needed, microliter to microgram. Last but not least is minimum thermal and catalytic decompositions sensitive sample component. While disadvantage of gas chromatography is first limited to volatile sample, next is not soluble for thermally level sample, then sample soluble do not react with the column. Last but not least is during injection with the gases, the proper attention is required. Topic is sample preparation. Food products that inject into gas chromatography cannot proceed without the sample preparation. So sample preparation involves reading, homogenization, or otherwise reducing particle size. So it needs the method of isolate analysis from food for gas chromatography analysis. So the method have 5 methods. First, head space sampling, distillation method, solvent extraction, solid phase, and lastly is direct injection. So we got the first of method, head space sampling. Head space method, so the specific method have 2. Direct head space sampling and dynamic head space sampling. So, direct is head space taken from a sample enclosed vessel for direct injection into gas chromatography, while dynamic is sample is purged with inert gas to stream volatiles from the sample and retained by absorbent or cryogenic trap. Next is distillation method. The specific method have 2. First, steam distillation, and then simultaneous distillation and extraction. Steam distillation is at normal pressure or in a vacuum. Use steam at atmospheric pressure or in a vacuum to heat and co-distill volatile from the sample. While simultaneous distillation and extraction of specific method is product steam and solvent vapor are intermixed and condensed, so the solvent extract organic volatile from condensed steam. Next is solvent extraction. Specific method of solvent extraction is 3. First, simple batch extraction. Second, continuous extraction. And lastly is solvent assisted flavor evaporated, or we call it SAFE. So, simple batch extraction is used typically organic solvent with example spiratory phenol to extract analysis of an interest into the solvent. While continuous extraction is used organic solvent or CO2 or carbon dioxide with equipment to make continuous. Lastly, solvent assisted flavor evaporated, or we call SAFE, SAFE for the short form. It is a sample with extraction solvent are added slowly to the SAFE device. Volatile and solvent are distilled and collected in the cold trap.
Another method of the sample preparation for GC analysis are solid phase extraction. Solid phase extraction has 2 types of method, which is solid phase micro extraction and the stir-bar sorptive extraction. For solid phase micro extraction, stationary phase is bound to find few silica filament. The filament is immersed in the sample or headspace of the sample and pulled into the metal sheet that is forced receptor of GC. Volatiles are thermally dissolved from the filament. For stir-bar sorptive extraction, magnetic stir bar is enclosed in a glass coated with absorbent film. The bar spin in the sample and absorb analytes, and then the stir bar is transferred to thermal desorption and delivered to GC column. Last one is the direct injection. For direct injection, we just inject 2 to 3 microliter of the sample directly into the GC column.